This video is about the rebuild of the 915 gearbox in my 1978 Porsche 911 SC. And the first thing I'd point out is that as a general guide and support, other videos are probably better. And I'd point you to the videos of the Classic Automotive Training School. And the gentleman who does that leads you through very nicely and very professionally. So thank you to them. However, this video has some special features that might make it worth your while looking at. In my case, I had what appears to be an older type of main shaft, and there was damage to that main shaft with chipping away of the flutes on the splines that are designed to hold second gear here. And this whole stack of gears could move by about 3 millimeters, which is causing a number of different symptoms. So I made up a collar and had that welded onto the main shaft to support that second gear. Secondly, the main pinion bearing outer race, which is sitting here on top of the differential case, it was spinning in that case, which is a common problem. And so I got some shimming and shimmed that in there, and that seems to have done a good job. And lastly, I made a bunch of different tools for doing the job rather than buying them. So the video follows now. It's actually made up of a lot of different clips, and so to some extent it's disjointed, but it tells the whole story over a number of months. So here is the input shaft for the 915 gearbox in the Porsche 911. The clutch at this end driving through the shaft. There's a stack of gears held together with this nut at 240 Newton meters. We have first gear, second, third and fourth, and we can slide the synchro hub in order to get third gear, and similarly for fourth gear. Now the problem with this particular shaft is over here. The second gear should be held hard against stops here in the splines where they've come up like so in order to make a hard stop. And what's happened is that these have worn and chipped away, so there's considerable movement, and this nut here is actually not doing anything. It's supposed to be held very tight in the stack, completely firm. Now the symptoms this caused was jumping out of third gear because third wouldn't actually get reached because this comes away, rattling in third gear, and in fourth gear, if we had it in fourth, and take your foot on and off the throttle, then the movement in this whole stack up and down, just a few millimeters, was enough to provide a movement of about an inch in the gear lever. So the solution is to put a collar over here, so machine these proud chipped flutes down, put a collar over a bit further than required and puddle weld it on, and then aiming to have this nut done up to the same position as it is, make some machining on the collar so that it comes to exactly the right position, and then we can tighten the whole lot up nicely to 240 Newton meters and not have that movement. Here is the main shaft broken up. So we're just checking for run out on the main shaft, and at this point we're getting somewhere around about just under 0.1 of a mil. And if I do it at the very end, it upsets the balance a bit, so it starts to give funny results and moves around. But that looks quite acceptable, I think. And here's the pinion shaft broken up. This is me making a tool to extract the dog teeth or gear teeth off from the first and second gears. Well, my homemade extractor worked rather well, and it popped out in the press rather quickly when I was just doing a test push. So here are the dog teeth, and they're sitting there turning around in a nicely molded backing which takes the teeth, and that was held in simply with the circlip that comes for holding in the synchros, and just with a couple of tons that pushed out quite easily. This was second gear. We'll have a look now at first gear. So here's my plate with the machine fitting to take the dog teeth, which are here on the gear. This is first gear. That fits there nicely, and then the circlip goes on here, and then we just push out down here. This piece is the gear pushed out from the dogs. My original plan is to bolt another plate in the top here with a recess to take the circlip to ensure that it didn't expand out of the groove. And when on second gear I gave it a bit of a test push, I found it popped rather easily. I'm now just putting a bit of pressure on this, and it's probably going to take a bit more. There you go. Didn't even register on the dial. So that's it pushing through. First gear came out quite nicely. So that's quite an easy and cheap fix to make a plate like that to extract the dog teeth, and that didn't take too much work and saved quite a few bucks. So this is third gear. I haven't taken the synchro mesh parts off, But you can see that the dog teeth are proud of the main gear, and that means it should be easier to take off. You can probably see there's a bit of a gap there, 0.4 millimeter between the two, which shouldn't be there. And that goes with the fact that the main shaft nut was loose because of the damage in the shaft. I found this exhaust flange, which fits quite nicely, and so I should be able to just push in here, and with a bit of heat on the dog teeth after taking the synchro mesh parts off, that should come quite easily. I gave that a bit of heat, but it doesn't seem it was necessary because it's actually going through rather easily. So that went well, and having put the gear wheel in the freezer and heated up the dog teeth, that just slipped on very easily. My dog gears went on very easily because of heating and cooling, but there is a weak spot pointed out by the arrow where the circlip goes in to hold the synchro band. And if you put a lot of pressure on that, it's possible you could collapse in that area. If that's the case, then you could use tool P226, which has a protrusion that goes into that gap and pushes the lower down, and it's more strong at that point. So the problem here is that the splines on the main input shaft were chipped and worn. I've actually machined them quite flat. You can see on the second gear the mark where they stopped. So that was where they came up to and stopped the gear at that position. And so the job now is to make a collar between here and here that when you tighten up at 240 or so Newton meters, this gear is held tight. So the first part of that is getting a piece of rod and first of all start drilling a small hole. Here we are here, and then make that bigger and bigger and bore it out and start to make the collar for this part of the main shaft here. We just make this hole a bit bigger and even a little bigger, and then continue by boring until the hole gets big enough. So I bored this hole up to just the right size. This is a very neat fit, and it stops right here where the flutes on the splines here were proud. I've machined them down to start off with. I'll machine them more until this is just a very tight interference fit, hopefully, and then this collar will fit all the way up to first gear right here and sit on it, and then I'll probably drill holes in it and puddle weld it to this part of the shaft so that it's tight, and I'll only puddle weld it when it's done up to very high torque against this first gear so that the welds don't take all the pressure. It's shared between the welds and this first gear. So some machining to do. I'll also cut a thrust washer out of this bit of collar for between second and third gear because mine was mashed up with all the movement between those two. So here's the collar now on the shaft, and it's a good tight fit drifted up against the gear which is part of the main shaft, the first gear. And this tube is a neat fit over this part, and I've cut a groove in the washer here to keep it central while we do the main shaft nut up tight to hold this in tight against this fixed gear. And I'll do it up quite tight before doing puddle welding through this hole and one on the other side, so that in the end the welding and the gear will share the stress of pulling up the gear stack at about 200 Newton meters. And to do that up, I've used my rotary table to help make a female splined part, and I will put flats on this or weld something onto it in order to make that something you can put in the vise and tighten up. Now you'll notice that the first gear, the driven gear, is actually quite a bit narrower than the gear on the main shaft, which will keep it away from that collar, but I've left quite a bit of meat on the collar so that if it did come out of place and touch, there would be an uninterrupted contact, because I don't want the teeth to interact with that collar. But that shouldn't happen. It's not meant to do that. And I'll check that's all nicely spaced apart when we assemble it. I asked my aviation mechanic friend Tony to do the puddle welding because he's a gun welder. Thanks, Tony. And here is Tony's good puddle welding, and I'm just having to take that back quite a bit to get clearance of the synchro ring and the selector fork as well, and also to shorten it down at this end, which it's about 5 mils too long. So that's the final machining, I hope, on the collar, and you can see the very hard puddle weld here. I've left it proud a little bit at the edges to take more thrust, but relieved it in the center to accommodate the synchro slider ring. And on final assembly, I might need a little bit of relief on the selector fork, but I think it'll be okay. This is the thrust washer between second and third gear, which got broken up when everything was loose. And so I've made another thrust washer. The thickness of this is designed so that the nut at the end of the main shaft will do up to exactly the same position as it did before. So this is the main shaft in with its welded on collar, and I maximized the diameter of that collar to give strength, and I've got, you can probably see, about a 1 mil gap to the synchro ring. I think that's probably acceptable. The selector shaft has got a 0.5 mil gap, which if I move it side to side, I can just touch that collar on the main shaft. So I'll relieve that rib just adjacent to the collar, and it'll probably not touch it at all. If it does, it'll wear itself in, but I think it's probably going to be away from there. So that's the gearbox essentially back together. This has been useful to have, this jig, although as a recommendation to whoever makes it, the tolerances could be a bit tighter. It's a bit loose and there's a fair bit of wiggle room in these gear shafts. I think in actual fact for positioning the selector forks it doesn't make much difference. I paid particular attention to the position of the dog teeth in relation to the synchro mesh and equalized that with about a 0.5 millimeter overlap of the dog teeth, the synchro mesh on both sides. And I got the clearance on this quite well, and I don't think that this wiggle will make actually much difference to that, but it would be nicer to have this being tighter. And over here you can see the collar which has been welded onto the main shaft, and the gap is quite acceptable. I think you can't see it very well because of light, but with that very small amount of relieving of that selector fork, the gap is there. And going forward in this direction is what it will be. It's a trailing edge onto this selector fork if it does touch, so that would run in quite nicely, I hope and suspect. There you go. And the next issue is broken head studs, which happen to be right here. That's another video. This outer bearing has been spinning in the case, and I've got a piece of shimming here I've cut, and it's just under 0.05 millimeters. And with a dry fit, that seems to go in there with what the right amount of tapping would be on the bearing, I think. So it's quite tight, but if I also use the Loctite primer and Loctite 680 on both sides of everything, well, hopefully that means it'll be quite stable. I think probably about as good as I can get. The other thing to do is just not use the shim, put Loctite in its own, and it probably is up for the job. The gap is probably something like 0.05 millimeter, which is well within Loctite. Although I somehow feel comfortable having a piece of hard material in there with the shim, and we'll see how it goes. I might abort the shim and just use Loctite on its own. So you can see that the shimming went in there quite nicely. I was quite lucky that it behaved itself. It's in there with Loctite and activator. So the Loctite now has 4 surfaces to work on rather than 2, but it's essentially an interference fit because I had to type quite a bit to get that bearing to go in there. And so hopefully that will give me another few tens of thousands of kilometers without any spinning in that bearing. And this area here is enclosed by housing, so that if any of that shimming were to come out with any movement, it's well enclosed, but I would keep an eye open for it. It's always a problem, apparently, with Porsches to have this bearing spinning, and the alternative is to machine out that whole part and put in a new section, which is very expensive. But hopefully this will do me for a good few thousands of kilometers ahead. So there's that outer bearing held nicely in the casing, and I've put the shims on, which are important for getting the pinion depth correct. And you can see there's been some movement of the intermediate bearing, which I've got here. This is the new one, not the old one, and that has been spinning to some extent. And there's a retaining plate, which I'll put on now. And that retaining plate holds it down clamped. But the fact is that when I do that, there's still some movement in this. And this is important also for getting the backlash correct on the pinion against the ring gear, because if this is able to move up and down, albeit by such a very small amount, about 2 or 300ths of a millimeter, I'd prefer to have that tight against there. So I'll take this bearing plate on a flat surface and polish it to take off about that amount of material until this intermediate gear is tight when it's clamped down. At the moment, when I clamp it down tight, it's still quite a bit of movement there. There's some free play which I'll take out. So after about an hour of polishing, that's looking dead flush, and I can't get any movement in there at all. However, when I clamp the plate on, the bearing, I can just turn it by hand, quite tight, but that means I just need to do a little bit more of a polish to take off a very small extra amount so that that bearing is well seated when it's clamped on. And after taking those shims out, I'm getting virtually no difference. It's still the massive backlash, which is much more than expected. Now I'm looking for about 0.4 millimeters here, which is equivalent to 0.15 millimeters on the ring gear, and that's because I'm measuring it at the pinion. And I've looked very carefully and I'm quite confident that the ring gear is not moving at all when I make this much movement in the pinion. So we've got far too much backlash, and that means the adjustment is not made by these shims. Most of that's going to be by changing the shims around in the differential, which I'll get to now. Now the design depth for the pinion, I haven't measured that. I'm going to first of all assume that these shims have been correct, probably from original installation, and I'll set up to get the correct backlash and then check the pattern of tooth contact on the teeth of the pinion and the differential to make sure that looks all right. I don't have the same facilities as the very good videos at the Classic Automotive Training School, and I would direct you there if you want to do this nicely. But this is a way of doing it which I think is going to give me some confidence if I get the tooth pattern correct with engineer's blue on these teeth. And this is probably the reason it was taken to bits. That's actually looking like a magnet having come out of the Speedo sender unit, and there's also evidence that the ring gear took it to the edge. The other thing is that the spacer on this side is 0.26 millimeters wider than the one on this other side near us, and that would cause the problem of the backlash being out if they had got those spacers the wrong way around. So that's probably what's caused that. And with the addition of a very fine shim, I've got the preload on the differential bearings working nicely, and what you see is a picture taken during motion. So with the pinion shaft nicely clamped, we can check the backlash on the differential, and that's coming in at 0.15 of a millimeter, which is printed on the ring gear. And that was achieved in the end by simply swapping over the two spacers between the two sides. And the one was much thinner than the other by about 0.3 of a mil, and that made a really big difference. It seems that maybe when they rebuilt it, they got the spacers the wrong way around, thinking they were the same, and they weren't, hence the very large backlash, which is now corrected. And this is a tool that I made just with a rubber bung in there, and it doesn't need much torque on it. It's just driving the dial gauge because I'm moving the differential from the other side. As you can imagine, I spent quite a bit of time looking at tooth patterns as a function of the shims that I used, and what you're looking at is a 0.19 millimeter shim giving a 0.17 millimeter backlash at the differential. So I've now got a 0.15 millimeter shim between the gearbox and the differential, and I'm getting a 0.13 millimeter backlash, possibly just a little bit more. That's very close to the specification of 0.15. And if the bearing blue markings on the teeth are acceptably close to the center, which I'm chasing, then I think we'll be about done for that. So I was looking for a pretty central tooth contact pattern, but it's actually gone rather well over all the tooth, and so I'm quite happy with that. You can see that my output flanges from the differential were quite badly pitted, even although they weren't leaking oil. And the part number you can see in the box there for the SKF Speedi-sleeve fitted quite well after taking just a little bit of material off the flanges. I also had to cut that part a little bit off in the lathe, as you can see, just to make it fit in, but that's been a good solution. Here's a good use for an old mower blade, and that's a standard clutch plate with no modification. That's the clutch together. Now these Sachs kits apparently don't come with clutch alignments tools, so I just made mine out of a piece of aluminium. And the beauty of that is you can make it a bit of a tighter fit, which that one is. It's really neat, and that means that everything lines up really well. So there's the gearbox, just over 50 kilograms, and having it on a sky hook like that makes it quite easy to put onto the engine, because it's very easy to tilt one way or the other if you hold it in the middle of the sling like that. This is our first test drive into first, and that would rarely happen like that before because of the dog teeth being worn. And then into second with a big crunch, but this time that doesn't happen because the synchro mesh works nicely in second, which was one of the problems before. Into third, and third would rattle. I think we've still got a little bit of something in the gear stick there, but it's not the big rattle we had at the back, which was due to the main shaft being worn at the top and damaged, and the whole stack of gears moving up. So that when you pushed it into third, it pushed the gears up, it didn't quite engage. The synchro ring wouldn't compress the band fully, the bit stiff through the gears, but everything's working just fine. Very happy. And here we are at speed on the highway, and another noticeable outcome is that the whine that we used to get, it was quite a pleasant sing, but that's gone. And that was probably due to the fact that the backlash in the differential was about 1.5 millimeters when it should have been about 10 times less than that. So that's us coming to the end of the video. You'll see I made a comment about third gear and something happening there. The same as what happens in my 1955 Triumph TR2, but a bit stronger. So I'll make a comment about that below, and any response is welcome. But all the symptoms that we had wrong with this gearbox have been identified and fixed, and the car's going well, back in regular use. Very happy indeed. Thank you for watching.